Welcome. My name is Jose Liendro. I'm a software engineer working here at Whitefront. And today I want to share some experience using ELK, APM, and bits. So let's start it. First of all, this is an OTT. It's an online tech talk. Here we want to share some knowledge between our partners and as well to the general public. So sometimes we share experience during the week, some research that we made, or some technology updates. So in this case, today, well, first, please subscribe and give us a like. We have this Whitefront YouTube channel where you can subscribe to getting update with all the presentations that we are doing. So please give us a like and subscribe. So today I will talk about ELK, APM, these words. First, I will try to define what they are and what we can get from this technology. So first of all, ELK was created by Elastic company, and it's a set of components. In this case, it has these three open source agents or systems. In this case, we have Elasticsearch, Logstash, and Kibana. And they will work together, and they could have like different topologies in the server side, and will help to store system logs and as well some metrics, dashboards, and will help to understand like what is happening in our servers. And in general, is distributed systems that can help to retrieve information. One of the things I lost to mention was that in this case, we will get some metrics, and those metrics will help to improve our system. We cannot improve something that we cannot measure with numbers. So this system will help to make that. So then we have as well another the fourth leg, which is the APM. In this case, belongs to the same family, and is a server that will get application data into our system. Here we can understand about our transactions, errors, performance, dependencies, and here we can get any error, runtime error that we can have on our system. As well, on the left side, you will see that there are different agents that will send information to the system. And as you can see, they could have like different technologies. We can have Node, Java, Python, and etc. My experience here was to use the Python agent over Django. And as well, the good thing is that we can have like the same stack with different agents. We can have like different technologies in the company, and we'll get all the benefits in the same way. And lastly, we have as well the bits. These components lives into the server, and they are a family. And the idea of the bits is to send information to the stack, to ELK, and they can inform about system logs as usual in our var log folder. They will forward real-time logs to the system, and as well we can have like different types of bits, different flavors. We can have, for example, metric bit that as well will send resources metrics like CPU, memory, network, and as well in case we are handling with containers with Docker, for example, we can have as well metrics about how they are working. So from the left side, we have here a set of servers that they have installed the bits, some bits family, and then in general, we will send information to Logstash that will receive the logs and metrics, and then the information will be stored in Elasticsearch, which is a non-relational database. And finally, we can make queries, get to the dashboard through Kibana. Here we can see all the kind of flavors that we can have. On the left side, we have the metric bit, health bits, file bits. Here in the experience that we can see later, we'll see file bit and metric bit, some results and some examples. So they are implemented in Go and works pretty fast and doesn't use an overkill of resources in the server. So they plan to be very fast and lightweight. So in general, the stack will propose to have a set of servers where Kibana lives in his own place. Elasticsearch as a data access layer could be implemented as a cluster, and Logstash as well could live, for example, with the APM server. So first of all, here we are seeing a server structure topology that I was working in the company. It doesn't matter the details, but in general, what we do was to create a monolithic application into a distributed systems in several servers, where we changed the installation process to use containers instead of daemon servers in Linux. So we want to retrieve information in a single place instead of getting to each server. We want to retrieve logs and metrics in a single place. In this case, the interface will be Kibana. So what we did is to install different bits along these servers, and we install the stack here, and on the right bottom where it says JobSync ELK, where we have all these services. They work by default in a set of ports. For example, Logstash is 5044, and so on. So the main goal here will be to, well, what is the easy way to get information from a set of server, or as well, if we have an auto scaling feature where we have like we have a dynamic amount of servers or lambdas or etc. How can we retrieve in a single place information? So here, for example, what I did is to share some screenshots about how the system looks. All these screenshots was taken from Kibana. In this case, we are accessing to the APM service. What we are seeing is the services. In this case, we have one line by server. So in a single place, we can list all the services in a company. As well, in this case, we are seeing everything in Python. But if you remember, the APM agent could be implemented in different languages. So that is a good thing because we can have the throughput, for example, the amount of transactions in average. And if we have errors, we will see in a single place. And as well, we can set if the server means like production stage or environments or a test environment. As usual, through Kibana, we can set a time frame where we want to explore the metrics or logs, and as well we can compare the current log with the same metric in the past time frame. So we can know if the system behaviors is similar or not to the last time we we were doing these queries. So, well, here I have my cat assistant, so you will as well hear. She's Ekate. And on the other hand, here with this view, here we will see the list of the servers with their performance, and here we can do a query about dependencies. In this case, one of the most consumed resources in the company was MongoDB, and it's a pretty common use cases to understand where we have the slow queries or where we are losing time. So in this way, we are seeing the MongoDB metrics, and we can filter what are the servers that are having like more delays or failures in this case. In the same way, we can get into a server in particular. Once we choose one of the services, in this case it's a server, the name is applied to, we can arrive to a section, different sections. First, we have the latency as the amount of time that the request will take to respond. And then we have the throughput, and we have transactions and an error section. And of course, the latency, we will have to maintain like a slow numbers in times. Here we can understand where we are having like timeouts, because all the timeouts will usually lives over a minute. So if we have some issue there, it's pretty easy to understand where we are having delays. As well, if in case sometimes we don't know if the system is like heavy in use because we have a lot of clients, or there is a special date, so we will know that through the throughput there. And then as well, we can have transactions over the system. Here we are listing these kind of views to get or post method. And as well, we can arrange. They have a metric named impact that you can see on the right side, where that is a component metric that will take the latency, the throughput, and the error rate, and we can follow and order the transactions by the impact that has to the system. And as well, we can have the current, the runtime errors and the amount of times that an error happens and when happened, and that is as well very useful. And this one, this is a dashboard that we built for a section in the company. This dashboard was made through Nginx logs. Here, what we did is to inference some applications entities from the way that it looks in a URL, for example. In this case, we are seeing like the amount of hosted pages, where they are coming from, if they come from some proxy or to the other one, where the most viewed hosted page, and if they have success or failure, or if they was redirected or has a client error or a server error. And this dashboard was made through only Nginx logs. It doesn't have like application breadcrumbs, let's say. This one as well, this is the application in this example. The application, it's like a very core application business metric, and it's pretty important to understand if we are receiving applications, which day, what is the behavior of the amount of application by day, or if we have an error. And as well, this dashboard was made through Nginx logs, and allowed to understand where they come from. Or on the right side on top, we will see if they come from a main server or an apply server, and as well we can track the amount of timeouts that we are receiving, and took some statistical information that can help to took some actions. Then as well, they have statistical data over an error. For example, this is a distribution diagram where we can study the occurrence of an error. So in this is a distribution diagram, and if we go to the tail, to the most, the worst transactions, we can go to the limits, to the corners of this diagram and study the worst performance query over a particular error, and review what is happening. We can arrive to the application views and going through a stack trace, and we can see the amount of time that took in each of the layer or the dependency for a particular view. And as well, we can took an example of the worst query and understand what is going on here. As well, we can study what the application, how the application works from this. We can, sometimes we have several errors, and it is important to take priority where we start working, where the more where. Yes.
I think your camera moved.
Oh, sorry. That's okay.
It's okay. Thank you.
Okay. Well, yes, because thank you about that. Yes, I forgot you're seeing me in the camera as well. Well,
you look good. You look good.
Oh, thank you. I don't have like a return, but
okay.
I think
sorry to interrupt you. Please continue.
No, it's okay. Well, here about the impact, or the metric that has this name impact, it's pretty helpful because sometimes we have a lot of errors and we want to go through the one that will have more benefits to us because it's heavy in use, or it has like a lot of timeouts, or it's the one that took like more time and produced timeouts, or it has like several errors. So the impact metric is a good, a kind of good friend that will help to order the work to be done. And as well, we can retrieve, in this case, the resources of the machine. Sometimes we are not aware about. Sometimes if we choose an algorithm or a process that it's heavy for the server, this will help to understand if we are maybe we are processing files or that kind of thing in memory, or we are not choosing a stream function or similar. We will be using the memory extensively, and as well, all this information will help to understand what are the dependencies or applications. These are external dependencies like MongoDB, Google Sheets, MySQL, or other microservices for a given server. And as well, we can understand what are the more common errors that needs to be resolved. And so in general, we were seeing different aspects of what that we can see in an implemented stack. So we can see it in action as well. But maybe first you have some questions.
I want to see it in action, but I don't know
Me
about
too.
anybody else.
And how to implement it.
Oh, okay. Well, in this case, we implemented everything as containers. We have like 3 main projects. If we want to going through production, first of all, this is an open source, so we can install it by hand in a server. But as well, we have some business license, and that they are very expensive. They are like $10,000 by years, and so once we want to configure this configuration in this stack, could be heavy to install because of the security that we want to have in production with SSL transaction. Once we have these components, Elasticsearch, Kibana, and Logstash, they could live in different servers, so they will use SSL and authentications. They will have different users in order to authenticate, and as well, the FileBit will use SSL and authentication. In this case, we installed everything with containers, but I think if we have an option to just having this stack or contract this solution from Elastic, or if you can choose to have Elasticsearch from AWS, maybe it could be a better or faster solution. But the benefits are pretty extensive. These are just some of the options that they have, but it has like a very long list of solutions. Well, here, for example, we are seeing like the very basic Kibana interface, where we have a list of servers. Here we are seeing like one of the latest versions, and the version is number 8. Here we can have we can know where the logs come from. As well, we'll have to connect like databases as MongoDB or MySQL. We can explore a particular time frame during the history. And here, then we can filter by the type of the log. Here we can have, for example, Nginx, Unicorn, let's see, Unicorn, crontab, and depends on the service that we are having. We can receive different logs, and of course they will have different structures. So we can use a query that is KQL to filter a given log. And once we want to go to the APM section here, you can click here in APM, and you will see the list of the servers. It is pretty awesome that it is pretty performant. It's a very fast system, and we can filter, for example, last 7 days for all the servers and review how they perform. And we can then, in this case, we can compare about how they work the previous week. And in case we get into a server, we will have this section, which all the sections that I mentioned earlier. And as well, because they are using like statistical concepts, we can move in the 99th percentile of because they took like a set of information. They don't show everything. So in case we want to study like the worst scenario, it's better to choose the 99th percentile of the occurrence of a log. And then if we go to a transaction, we can study each transaction in detail, how a view is working. Here as well, it's nice to see how it looks during the week. It's good to see how these resources what is the behavior, or if we have some difference, we can then go to study what happened here in this particular time. And this is the latency distribution. So we can choose, for example, if we have, in this case, we are near we are near a minute, we can then study for this particular transaction why is like why it produced like a failure, or it produced a timeout. In this case, it is consuming an S3 element, and because of that, here we spend like more than a minute. And then as well, we can go through the dependencies of the application in general, and we can understood what are the services that consumes more dependency. For example, a dependency could be a database, for example, MongoDB. So here, for example, you can see how so it has like a slow latency, but it's heavy in use. Because of that, the impact of these dependencies is like high. And then we can review all the services that consumes the database. Once we have, I think that the hard part of the configuration is how to configure the ELK, but then it's like a pretty awesome tool to use. So this is like the demo. Last week we received feedback from a customer saying like we are having like timeouts accessing resources. So without more information, we can understand what's going on, and then go back to the previous week to study what happened and what happened with a resource in particular, and going through very in deep with the details about the error. And so it's a pretty powerful tool. And I think the best option here, we are not seeing like configurations part, but if we want to see how it is an APM agent implemented, we will have it is like a middleware. It's just, we just need to install, for example, in a Django project, it's a matter to include a middleware named APM agent, and that's it. We will have all this information just to installing the agent, and then we can have Node and other technologies. So that's okay.
By the way,
Einstein?
thank you. Yeah, cool name, huh? Thank you for thank you for this. This is super interesting. I have more of a technical question regarding indexation. So say, for example, we've already indexed many thousands of documents, and we want to add documents that have a different structure than the ones that are already indexed. I've had difficulty in the past reindexing straight up on the same index. How do you approach this from your experience?
Well, in this case, we are indexes we have a set of indexes. We have file bits, metric bit, and the APM index, and we store by date. So if we want to the discovery section, we have a file bit, metric bit, and APM indexes here. The index is for a day, and then we'll receive everything there. And here we are posting like different structure, and maybe when we install the file bits, you need to, I'm not sure if that is the case for you, but you can install like how you will parse a document. And I never did like a re-index process. I just create the source. Maybe we need to do some fine tuning in Logstash, but then around the index, what I did as well was to work with the ILM to manage the lifecycle of an index, and where they are where they will get, let's say, or Elasticsearch offer like different types of history of logs. They have a hot spot, a cold spot. So if a log is too old, we'll change, we will be stored in a different place, maybe an S3 bucket. And they have different types to store, to manage like the indexes.
Thank you. Interesting stuff.
You're welcome. As well, when we were working with the ILM, we need to as well to run some queries, because in this history, in this experience, we want to study what happened with MongoDB. And by day, MongoDB produced like 20 gigabytes of logs. So if we want to store like months or years of log, it's like a lot of terabytes to process. And we as well, it needs to change the type of servers that we are using in AWS in order to handle more than 3 terabytes of data. I think it's, instead of MBR, we use GPT type of disk drives. But in general, I didn't do like a reindex process here. I just delete index or receive information. Also, if we don't have more questions, I think this is the end. Thank you for your attention.
Awesome, Jose. Thank you.
Thank you, Jose.
Thank you,
You're
Jose.
welcome.
Thanks for sharing.
Great presentation. Have a
Oh,
nice
great.
weekend, guys.
For a nice weekend.
Thank you all, bye, guys. Bye-bye.